Okay, let's take a look at the next section of this, where we actually get to use Pythagoras in circles. Okay, so a special type of question occurs when we have an isosceles triangle inside a circle, and we're asked to find or use its height. Now, I'll start off by saying the most important thing that we can know in any circle question is always going to be the radius. If you know the radius, you can do anything with that. Because like I said in the previous video, if you know the radius, you can make isosceles triangles, which you can then have to make into right angle triangles. Okay? So, exactly what I just said there, it said in the third line down here, so it says, to use Pythagoras' theorem, we need to cut the chord in half to make the right angle triangle. These questions are very common in exam situations and can sometimes be in the context of a train tunnel, a tanker, a pipe, or anything where part of the circle has actually just been cut out. Okay? So what you have to remember here is that the radius always bisects the chord at right angles. Okay? So, example 4, it says a tabletop is in the shape of part of a circle. The centre of the circle is O. AB is a chord of the circle, which has length of 70 centimetres. The radius OA is 40 centimetres, and I want to calculate the width of the table. So the width of the table is this height going from the top to the bottom. So straight away, I know that this distance from here to here is also going to be 40 because it's a radius. I also have the radius going across to here. Oh, ignore that sound. So I have the radius going from here to here. That allows me to cut it in half at right angles, so we can assume that this bit here is going to be 35. So if that's 35 and this is 40, what we can say is that we now have a right angle triangle where that's 40, that's 35, we have a right angle, and this bit here is x. Okay? So using Pythagoras, we can say that x squared is going to be 40 squared take away 35 squared. So let's just process that. So that's going to be 1,600 take away 35 squared, which is 1,225, which will give us 375. So x is going to be the square root of 375, which will give us 19.3649. So therefore, x is approximately equal to 19.4 centimetres, so 1 decimal place. So what we now want to do, because we know that this bit from here to here is now 19.4, and we know from here to here that's the radius of 40, we just add them together, so it's 19.4 plus 40, which will give us 59.4 centimetres, which is the width of the table. Okay?